Alright, so today we are going to be starting off with I can find the distance between 2 points using the distance formula. And then whatever the date is, you're going to put the date to the side as well so you can come back to that. So the first thing we're going to talk about is the distance formula. So when we're talking about the distance formula, it's going to look really messy at first, but I promise it will make a lot more sense soon. So the distance formula, we're going to have d equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And then somehow I'm going to make this stand out on my paper, so I'm going to outline it because this is a pretty important thing that we're going to be talking about for the next couple days or so. Okay, so what do these x sub 1s, y sub 1s, x sub 2s, what does all of that mean? So what that means is when we have 2 points, we have x sub 1, y sub 1. That's our first point. Then our second point would be x sub 2, y sub 2. So this is how our points are lined up when we put them into our equation here. So let's go through an example. Hopefully that'll clear some things up. So example 1. Maybe we have point R at 5, 1, and point S at -3, -3. Okay, so when we're looking right here, we're going to start labeling these with our x sub 1s, our y sub 1s, all that fun stuff. So if we refer back to what it should look like, we're going to have x sub 1, y sub 1, x sub 2, y sub 2. And this goes in the same way how we talk about our coordinate points. We have an x and then we have a y when we're talking about coordinate points. In this case, we're just labeling them with these sub numbers to show that, okay, this is our first set of points, this is our second set of points. So from here, I like to show these with different colors to make sure I have them all lined up properly. You can do this if you want to. It is by no means a requirement, but it is something that can be helpful at times. Excuse me. All right, so I'm going to start off by writing my formula under here. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And I'm taking the square root of all of this. All right, so now when I start to replace things, I'm going to put in each of my different points. So it's telling me I'm starting off with x sub 2. So starting out with x sub 2 here, we have -3. Then we're going to use x sub 1, which is 5. And that quantity is going to be squared. Then we have our y sub 2, -3, minus our y sub 1, which is 1. Okay, so now we have substituted. Our first step here, we substituted. From our substitution, we're going to simplify inside the parentheses. This is because we always start with parentheses when we're talking about PEMDAS. So, following that, negative 3 minus 5 is going to give me a negative 8 squared, plus negative 3 minus 1 is a negative 4 squared. Okay, so now I've done my parentheses, which leaves me with my exponents now. So I'm going to have negative 8 squared, which is negative 8 times negative 8, 64, plus negative 4 times negative 4 gives me a positive 16. Move this down. Then, following PEMDAS, I only have one last operation here. So now I have the square root of 80. That square root of 80 doesn't really mean much to us, so I'm going to have us do these two squiggly lines, which if you remember, that means approximately. It's not exactly equal to this because we're going to be rounding, but it's approximately 8.94. So the approximate distance between these 2 points is 8.94 units. Because it doesn't give us a unit value, that means that we're going to put units as our unit of measurement. And then that is how we solve. All right, so let's go over our steps of what we did here. So with our steps, for our first step, step 1, we substituted. Then for our second step, step 2, following PEMDAS, we simplified the parentheses. Then for step 3, following PEMDAS, we did our exponents. For step 4, we did our addition, following our PEMDAS. And then our last step, step 5, was to take the square root and to get an approximate answer. So at first when we looked at this huge formula up here, this looked like a giant mess. Like, what in the world are we going to do with it? But then once we are able to break it down, all we're doing is substituting and then solving using PEMDAS and then solving using our calculator. So in reality, this huge mess is not quite as big of a mess as it looks to begin with. All right, let's do one more example here. All right, so for this example, you might see something where you have the coordinate points in a plane. So we might have a coordinate plane here. And then it might tell us this in our line. So if I mark out my little marks, and I draw my line on here, let's say if I had a point up here, and then I had a point down here. And I'm labeling my points as A and B. Okay, so our first thing that we need to do here is to make sure we identify our points. Because if we look up at our first example, we can't do anything until we have our points. So, talking about our points here, we have our points. And A is at -5, 5. And B is at 1, -2. That should be on that little part. So let me fix my dot so it actually looks like there. And then if we would like to, we can label these x sub 1, y sub 1, x sub 2, y sub 2. And then if you like the colors, you can pay attention to the colors. Again, it is not necessary, however. All that we're showing here are like x sub 2 is equal to 1 and y sub 2 is equal to -2. Okay, so what I like to do is I like to rewrite the formula. That's not necessary for you to do. I just find it to be helpful. Let me see if this is even going to fit on my page. It's kind of close, so I'm going to go over here. So my distance formula is my x sub 2 minus x sub 1 plus my y sub 2 minus y sub 1 squared, and taking the square root of that. Okay, one quick thing to mention. It does not matter if your first point, which one of these is your first point and which one's your second point. You're still able to find the distance between them. As long as whatever you pick is consistent, then you are fine. Okay, so if we fill this in now, I'm just going to put all of these here so I have less pen swapping. Okay, so first we're starting out with our x sub 2, which is 1. Then we have our x sub 1, which is a -5. Then we have y sub 2, which is a -2. And we have y sub 1, which is 5. Okay, so now we've done our first step. We substituted. Our second step tells us to use our parentheses. So now, using my parentheses, I have 1 minus a -5, so 1 plus 5 gives me 6 squared. -2 minus 5 gives me -7, and then squared. Okay, I've done my parentheses. Now I'm moving on to my exponents. So now I have 6 squared, which is 6 times 6 gives me 36. -7 squared is -7 times -7, so 49. Then I do my next part of PEMDAS, which is addition. 36 plus 49 gives me 85. And then because square root 85 doesn't really mean much to me, then I'm going to say this is approximately 9.22 units. And if I look here, that could be about 9 units, right? Yeah, extending on, it looks like it's about 9 units. So we're heading in the right direction here. All right, and then that brings us to our final answer.